Okay, folks, so in this video I want to show you long division one more time, and practice it one more time, but also I want to highlight a little bit more about the steps of this procedure. So just some vocabulary here. Here I've got a rational function. This whole expression right here is a rational expression, and it also, though, denotes the operation of division. So there's two ways to look at this. You can look at it as a fraction, or you can look at it as the division operation. And if we think about this as the division operation, we call the thing that we're dividing into the dividend, and we call the thing that we're dividing by the divisor. Okay? We're not going to use the term dividend all that often in this class, but just putting it all there. So let's go ahead and perform our long division. So we'll take our divisor, 5x squared plus 2, and we're going to long divide it into the dividend. So we get 20x to the fourth. And now notice here in this case the degrees, they're descending as they should be, but we have degree 4, then followed by degree 2, degree 1, degree 0, so we're missing a third degree term. In some cases this can get us into trouble, so it's good practice to put a placeholder there for that 0x cubed as if it were there in case we have an x cubed term for lining up the long division. Then we go ahead and include our quadratic term, minus 27x squared plus 3x minus 6. So I've set this up as actually performing the long division, and here we go. Let's go ahead and do so. So I ask the question, what do I need to multiply 5x squared by to make it look like 20x to the fourth? And the answer is 4x squared. Now we perform the multiplication, so we get 20x to the fourth, and then we get plus 8x squared. Now here we have to make sure we line it up under the correct column in order to make sure our sums come out correctly. And then remember, we induce the minus sign as we add down, so the 20x to the fourths add out as they should. If I had an x cubed term, it would come down. And then when I combine these two terms, we get minus 35x squared, and I'll go ahead and bring down the linear and constant term as well. Then we ask the question, what do I need to multiply 5x squared by to make it look like minus 35x squared? And the answer is minus 7. So then we perform that multiplication. Careful to line things up in their appropriate column. It's easy to make a mistake with that. And then remember, we induce the minus sign and we subtract down. And when we do so, of course, the 35x squared terms cancel. That's why we've built this. They're supposed to add out. And we're left with a positive 3x, and then careful here, we have minus 6 minus a minus 14, or minus 6 plus 14 gives us positive 8. So what we notice here is that the degree is now smaller than our divisor. So we stop. So at this point, I'm ready to go ahead and rewrite k of x as having performed this long division. So I'm going to write 4x squared minus 7 plus, and then I'm going to add to it my remainder. This is the 3x plus 8, all divided by my original divisor, 5x squared plus 2. So as a reminder, this is our remainder. As a reminder, it's our remainder. And I'm going to run out of room as I try to write that, so let me put it over here. And then I just ask you, because we have all these parts here, I want you to identify the quotient, divisor, and remainder. So the quotient is the result of having performed the long division. So our quotient in this case is just the 4x squared minus 7. The divisor was what we originally divided by, 5x squared plus 2, and the remainder in this case is the 3x plus 8. And I'm asking you to learn how to keep track of these parts, and I'll just say that this will be important next unit. We'll be interested in that remainder term later on, especially when that remainder term comes out to be a line. Okay, so folks, I'll leave you to try that one more time. Go ahead and perform the long division, and there'll be a solution awaiting you to check your work. Give that a shot. I hope this made sense. If you have questions about it, especially over the terminology, feel free to come by and see me during office hours. I would love to help you with it. All right, take care.